All right, so in this question, we are looking at 2021 AP Calc AB FRQ number 5. This is an implicit differentiation question, so it says consider the function y equals f of x, and it gives us an equation for this curve, 2y squared minus 6 equals y times the sine of x, for all y values that are greater than 0. So letter A, they give us an answer, and they actually just tell us to show that this is the correct answer. So they want us to show that dy dx is equal to, and they give us what this is equal to. Well, I'm literally just going to start this problem by writing down the original equation and differentiating both sides of this with respect to x. Okay, so I'm going to go ddx on both sides right here. Okay, I'm going to make a note. When I have dy dx, I'm going to notate that with y prime, so I don't have to keep writing dy dx. All right, so let's try 2y squared. This can be 4y times y prime. Okay, and then the derivative of the constant 6 is 0. All right, on the other side, I'm going to need to use the product rule. So I've got first y times the derivative of the second. Derivative of sine is cosine. Okay, plus the second sine of x times the derivative of the first. Derivative of y with respect to x is y prime. I would like to get everything that has a y prime on one side of the equation, so I'm going to subtract sine of x times y prime from both sides. Okay, I will now factor out the y prime. Y prime times 4y minus sine of x equals y times the cosine of x. Okay, and then last but not least, I will divide both sides by 4y minus sine of x. So when I'm finished here, I get y times the cosine of x divided by 4y minus sine of x. Okay, and that's what they were trying to get me to show. And so I guess I'll conclude this by saying, therefore, dy dx is equal to y times the cosine of x divided by 4y minus sine of x. Okay. All right. So not too bad on the first one, just taking a derivative using implicit differentiation. Okay. Next up, it says write an equation for the line tangent to the curve at the point 0, 3. Every time I write tangent lines, I like to say, make a note, I need a point and I need a slope. Okay. Well, they were kind enough to give me the point right off the bat. To find the slope, I need to plug in to dy dx. Okay, so everywhere I see an x in dy dx, I'm going to plug in a root 3. So I'm going to go back over here to this problem. So this is going to be square root of 3 times the cosine of 0 divided by 4 times the square root of 3 minus the sine of 0. Okay, now let's just do a little bit of math right here. Cosine of 0, it's on the right side of the circle, that's 1. Sine of 0, on the right side of the circle, that's 0. So when I'm finished here, I get root 3 divided by 4 times the square root of 3, which gives me a final slope of 1/4. Okay, and then last but not least, right here, if I want to write the equation of the tangent line, I'm going to go y minus the square root of 3 equals 1/4 times x minus 0. Okay, so there is the equation of my tangent line for this function. Okay, all right. Not too bad for the first two parts. Starts to get a little bit trickier though when we get over here to letter C. So letter C says from 0 to pi and all y values greater than 0, which I'm assuming they're giving me this to help me give me a direction on something. So we'll think about that when we get to it. It says find the coordinates of the point where the line tangent to the curve is horizontal. Okay. Well, a couple connections we need to make. Dy dx is equal to 0 when tangent line is horizontal. Okay, we can think about this. When a tangent line is horizontal, that occurs, for example, at a relative max. Okay, and so horizontal tangent line has a slope of 0, so derivative of 0. So we're really trying to figure out when dy dx is 0, and we want to find the x and y value for that point. Well, again, we already know what dy dx is. We should zoom out a little bit and look at it again. Dy dx is equal to y times the cosine of x divided by 4y minus sine of x. Okay, and so in order for this to be 0, again, we're looking for where is dy dx equal to 0. That means that the numerator here would have to be 0. So therefore, we could say 0 is equal to y times the cosine of x. Okay. I apologize. I'm sitting outside right now while I'm filming this, and I've got other things happening around me. I have planes flying over, so I'll let that clear out. All right. So in order for this to happen, we have a product here, one thing times another. The product's equal to 0. So this could either happen when y is 0 or when cosine of x is 0. And keep in mind, we are thinking between 0 and pi here. As the problem says. Really, I guess I should put brackets here. Okay. It also says y has to be greater than 0, so I can eliminate this because y cannot be equal to 0. But I can figure out when the cosine of x is equal to 0 by just thinking about the circle. Where does this occur? Well, this occurs when x is 0, so this would be at the top of the circle where x is pi over 2. Okay, so I have half the coordinate right now. I have when x is pi over 2, but now to find the y value, need to go back to the original equation they gave us, and I need to solve for y. Okay, so I'm going to go ahead and do that. We've got 2y squared minus 6 is equal to, I apologize for all the scrolling here, y times the sine of x. But everywhere I see an x, I'm going to plug in pi over 2, and then I'm going to solve for y. Okay, so let's give it a shot. Sine of pi over 2. Sine of pi over 2 is at the top of the circle, so this is 1. Okay. And what we have left when we're done is a quadratic. I'm going to go ahead and get one side equal to 0. This is 2y squared minus y times 1 minus 6 is equal to 0. And let's factor this quadratic. Okay. I apologize. Got another plane flying overhead here. 2 times negative 6. This is how I like to factor quadratics. 2 times negative 6 is negative 12. 2 factors of negative 12 to add up to negative 1 would be negative 4 and 3. Okay. But then I need to divide out a 2 from all of this. So when I'm done here, I get y minus 2 times 2y plus 3 is equal to 0. Okay, and when I solve these, I get y equals 2 and y equals negative 3 halves. Keep in mind, earlier in the problem, they said y has to be greater than 0, so I'm not going to keep that answer there. I will keep the y equals 2. And putting these together, I get pi over 2 for x and 2 for y. Okay, so these are all the spots, or the coordinate of point where tangent line is horizontal. Tangent line to the curve is horizontal. All right. Very algebraic problem, but if we can make the connection right off the bat, the derivative has to be 0 there. It kind of gets us headed in the right direction for the remainder of the problem. All right. Letter D now says, determine whether f has a relative maximum, a relative minimum, or neither of the point found in part C. Justify your answer. Let's write down what we've got so far. The point that we just found was pi over 2, comma 2, and dy dx. I'm going to make a note here since we're talking about relative max or mins. Dy dx is equal to y times the cosine of x divided by 4y minus sine of x. Okay, so what I like to think about here is, well, in order for a relative maximum or minimum to occur, dy dx has to be equal to 0. Okay, well, we already know from the last problem that this point does have a dy dx value of 0 because that was kind of how we began the problem in the first place. Okay, so I know that at pi over 2, comma 2, dy dx equals 0 from part C. Okay, which means it's definitely not neither. Well, it could be neither, I guess, if we didn't actually change directions. But it is a candidate for relative maximum or minimum because of the fact that its derivative is 0. Now, a couple different ways we could do this. We could try the first derivative test and pick points to the left and right of pi over 2. However, if we chose to do that, we would, if we go back to the original equation, 2y squared, let's see, 2y squared minus 6 equals y times the sine of x. If we went back to this original equation and tried to pick some other x values, we would then have to go back and solve for y for those x values, and that could get a little tricky. So what I'm going to do instead is I'm actually going to use the second derivative test and try to see, I know that the derivative here is 0, so if I can figure out the concavity at this point, that will tell me whether this is a relative maximum or a relative minimum. Okay, so what I'm really going to do here, if I call this y prime, is I would like to calculate y double prime. Okay, I'm going to need to use the quotient rule to do this. I'm going to start out here low times the derivative of the top. Okay, derivative of this is first times the derivative of the second plus the second times the derivative of the first, y prime. Okay, it's going to be a big derivative, minus high, so cosine of x, d low, so it's going to be 4 y prime, minus derivative of sine of x is cosine of x. Okay, all divided by low squared. Okay. Now, here's the thing. I'm really just concerned with what the coordinates, what the value is here when I'm done of the second derivative. I'm just trying to figure out if the second derivative is positive or negative. So I'm going to go ahead and I'm going to start plugging some things in. 4 times 2 is 8. Okay, the sine of pi over 2 is 1. Okay, so there's that first set of parentheses. The second set of parentheses, 2 times the sine of x. Let's see, so 2 times pi over 2 is, or 2 times the sine of pi over 2 is 2, plus the cosine of pi over 2 is 0, so I don't even care about what's happening after that, minus cosine of pi over 2 is 0, so 0 times anything is 0, so I don't really care about all that. And then on the bottom here, 4y minus sine of x squared, that would be 8 minus 1, 8 minus 1 squared. Okay, and when I'm done with that, I already know that that's going to give me a positive value. So when I'm finished here, I don't even necessarily, I'm not even necessarily concerned with, you know what, I just want to make sure that I do have, in fact, 1 second, let me double check. I want to make sure that I'm tracking the right way here. First times the derivative second. I did realize that actually this should be not y times sine of x, but this should be y times negative sine of x right here. Apologize for that. Because the derivative of cosine of x is negative sine of x. So let me back up, and I think that might actually be kind of important right here, because now this is actually a negative 2 plus 0. So let's think now about what we would have. 7 times negative 2, that would give me a negative number on top, and I could calculate the bottom if I want to, but I'm taking something and squaring it. So I know that this has to be positive, which means when I'm done, the second derivative is negative. Okay. So if we're thinking about how this applies in the context of the problem, I know that at pi over 2, comma 2, y prime is equal to 0, and y double prime is less than 0, which means this has to be concave down. Well, if we think about what that looks like visually, we know that we have some sort of critical point here, but if we're concave down, that means we have to be curving down at that point. Okay, and if we just look at what this means that at this point we must have a relative maximum. Okay, must have a relative maximum. All right, so kind of a very specific problem there with the second derivative test. However, conceptually it does make sense when we start to think about how the concavity comes into play with something being a potential critical point. All right, it is a critical point, but a potential relative maximum. That concludes number 5 here from the AP free response. Hopefully it made sense.